exercise is a pretty interesting question. So it's saying if you had a circle, right? Instead of having all 6 points, you only had 5. So like, how did they draw it before? You have to like, let's just kind of draw it. A, C, E,
B, C.
It's like A, B, C, D, E. And then F maybe can lie somewhere else now, right?
Yeah. Yeah, I don't know. Somewhere far away. I'm gonna draw that.
Yeah? But it's saying that these L, M, and N are still collinear.
Yeah.
So what's L, M, and N?
Just like connect A, B.
So it's like this, yeah? Like this, yeah?
C probably. This one.
So basically it's saying if the red line is still collinear, right?
Yeah.
Then F actually lies on the circle too.
Yeah.
Right? And all its other versions of this.
Yeah.
Yeah, so you made a really good point, yeah? So, for example, you could start at the, like thinking of the proof, yeah? You have the conclusion, which is like these 3 fractions times together give 1, yeah? And then we have all these other things in the proof for collinear, right?
Yeah, and they still.
So that didn't use the circle at all, yeah? So the only, so if you think about all that, so that's equal to 1, all these other things are cancelling, right? Okay. Because of power of a point, yeah?
Yeah.
So the only thing that doesn't cancel is the ones with F in it, right?
Yeah.
Okay. And so you get some term left over with A, MF, right? AM, and you get oh, sorry, yeah. So it's not the power of F, right? Because the power of F is the same, right?
Yeah.
It's the power of these two, yeah?
Yeah.
So you have 2 things that aren't cancelling, yeah? So you have, what do you have? So you have, what's it? Is it an N, L, N, L? This is M, yeah? This is N. That's L. So the things that you don't cancel is you have, do we have an EN on top? The EN was, did we have an EN? Okay, so it's a good thing we didn't have both of these, right?
Yeah.
If we just had one of them, that'd be good, right? Because you have both, you don't know how they interact with each other. But if you just have one of them, it's good, yeah? And we didn't have the EN, okay?
Oh.
If you remember. Yeah? But we did have the MF. Did we have the MF? Oh. What did we have? We had W.
What does that even mean?
So what do we have? We had VF.
V. Oh wait. Oh yeah, V.
What kind of stuff do we have? We have VF. Where's V? V is here, yeah? That was V, yeah? Yeah, there was definitely a VE and a VF, yeah? And that was in the denominator, okay?
Yeah.
And that would have cancelled with VB and VA, yeah?
Oh
Oh. V and VF. Why isn't there a VA and a VB, yeah, on the numerator?
Yeah.
Okay. So hopefully there's not too many more V's, many more F's, yeah? Okay, so that's a problem. There's another F in the numerator.
Oh.
F U. Okay.
F U. No, that's
I see what happens when you don't get to where you want.
Yeah, F U.
F U.
That's the magic show. What?
So where is U? U is. Oh, U is. Oh,
The trophy literally says F U. Oh, yeah. Because if you fool them and tell people, then they actually get mad at you. But if you fail, they just go like, that's a pretty cool trick there.
Okay, so U was up here last time. So we have like.
So like basically you have to like try and make them like not understanding magic.
So U E F U, yeah.
You did? I watched the. Yeah.
So U E F U. And
that just cancel each other out. Like that didn't even hurt. Did it hurt you? It just cancelled.
U E F U and U C U D, yeah? U D U C. Okay.
Odd.
Yeah, so there's the F appears.
It is F U.
The F appears once on the top and once on the bottom. Yeah, so these two things. So everything else is 1, right? So we have the product of these things is 1, yeah? Yeah?
Yeah, but what?
So it's not clear that they both have to be 1, right?
Yeah.
Like if they were 1, then that would be good.
Sure, cool. Wait, just an extension of they
times together to equal 1.
Which,
yeah. Oh, yeah, that's what you write now.
Oh. Yeah, so timing together is not enough, right?
Yeah.
To conclude that the power is equal. So the power of V times, so the power of V is the top, and this is the power of U on the top.
Yeah.
U is up there somewhere.
U.
So there's the power of V on the top and the power of U on the bottom, yeah?
Yeah.
And then these two things, you're hoping they're powers, but you don't know what they are. Yeah?
Yeah.
Yeah, so that doesn't quite work, yeah?
Oh.
I guess there's a kind of thing in geometry with converses. They always kind of, you use the theorem to prove the converse. Yeah?
Oh.
So, kind of like, you have a point F, right? So I don't know if this is going to work exactly, but look at this for the idea of what we've been doing before, okay? So you have F, so you have this other point F here, right? F prime.
Yeah.
That, you can join that to A, say. Yeah? You see?
Yeah.
And so because it lies on the circle, right?
Yeah.
Then the intersection has to be collinear. Yeah.
Oh, and that can't be good.
Yeah, so that kind of forces M to be there, right?
Yeah. So then F.
Yeah, so if that forces M to be there,
Yeah.
then A, M, and F is prime is collinear, right?
Oh.
So that forces F to be on this line now, yeah?
Yeah. And it has to
That means they're on the same direction. Smart. But does that mean that M is also on that line? Question mark, question mark, question mark. That's kind of...
Wait, so does that force F to be on the circle?
I think it was. Wait.
So let's just say for now the F is on this line, yeah? It's here now, yeah? What would happen then?
Then you can do the same
Same on the
thing.
other side, yeah? So join this thing. Oh no, it has to be on that line already, yeah?
Oh yeah, because
But we already said it was on the definition, it was on that line, yeah?
yeah. So then.
So if it's on both these lines, then it has to be here. Yeah?
Mm-hmm.
Yeah, that's pretty much how you prove like the converse of almost every theorem I've seen. You know, like cyclic quads, all that kind of stuff. It's always just like imagine what happens when it's on the circle.
Yeah.
And then
Kind
it's
of
a straight line.
forces the other. Yeah, like Pythagoras as well. Remember?
Mm-hmm.
It's
The
like
converse of Pythagoras.
so if they
What?
Oh yeah.
So if they add up to a square like that, then you can just construct the hypotenuse,
Oh yeah, you make.
and then that would have to be the hypotenuse, right?
Mm-hmm.
Because it'd be congruent.
Yeah.
So
Wait, what?
yeah, so it's basically kind of like the uniqueness.
What did you say? I didn't understand.
The uniqueness, yeah.
Yeah, Pythagoras.
Yeah, I know that.
How do you prove the converse?
What is
That A squared, like if you have a triangle and A squared plus B squared equals C squared,
Oh,
then
that's-
one of them is right
No, maybe there's an opportunity here. Can you see if it's 4 points, does it work instead of 5?
angle. Probably not.
I see how that works.
Wait. 4 points. And are all. No, because then you could have like, if your points you didn't know were A and D, you could have D on DF and A on EC.
Then it'd be Pappus, right?
And then the other one.
Very good. Yeah, so you know Pappus has it so that you can have 2 straight lines and not be on a
Yeah.
circle, right? So 4 points wouldn't be enough to force the other 2 onto the circle.
Yeah.
But 5 is. Okay.
Because you can't make 2 straight lines.
Yeah.
Easy
Should I
chord
just-
bash.
Yeah.
But why?
Should I? Yeah,
You
should
don't have